Welcome back, engineers. In this video we'll be solving a pretty complicated problem about a set of tweezers acting as a lever. So let's take a read here. While assembling a project, an engineering student uses tweezers to compress several different springs. The efficiency of the pair of tweezers is 88%. The student knows how much force each spring requires to fully compress according to the manufacturing label. Find the effort needed to compress each spring. Below that we have a data table about three separate springs, steel, silver, and brass, each requiring different amounts of force because they're made of different materials. And we need to figure out the force applied to the handle. Now that's going to be the effort force. The force from the spring, that's our resistance force. Okay, let's take a look at the diagram because there's an important part of that we need to understand. Our effort force is happening at the center of the tweezers. Well, not quite the center, but the middle. Our fulcrum is over here on the left side of the tweezers, and our resistance force comes from the springs pushing back on the tweezers. So this is a third-class lever because our effort force is in the middle between the fulcrum and the resistance force. Let's look at the measurements because these are important here. I'm going to draw some dotted lines. This distance here would be the effort distance. And then this distance here would be the resistance distance. So we are given some dimensions here. We have 4 inches and 4.5 inches. So if we just do some quick thinking here, the effort distance is 4 inches, and then the resistance distance would be the addition of those two, which would be 8.5 inches. Again, with this problem, I can keep things in inches, that's fine. As long as I'm consistent, I do not need to convert anything to feet. If I had an answer over here that was looking for a foot measurement, I would need to rethink things, but we'll keep things in inches for this problem. So, let's start to think about what my givens are. Well, for each of these springs, we're told the FR. We also know DE is 4 inches, DR is 4.5 inches. We know the efficiency. It's 88%. Oh, you can't see any of that, huh? Let me fix that real quick. There we go. That's better. Okay, what are our unknowns? Well, the things that we don't know is we don't know any of the effort forces, and we don't know the AMA or the IMA. And that's about it. So let's take a look and see which equations we can use. Now you'd probably think, hey, we just need the force, the effort force, so let's just go straight to the equation that involves effort force. Let's look at that. The equation that has the effort force involved is this middle equation up here, AMA equals FR over FE. But the problem is we do not have the AMA of the machine, so we can't quite use that equation yet. Could we get AMA? Could we solve for AMA? Well, we could use maybe the third equation to do that, but the problem there, we do have percent efficiency, we don't have AMA, and we don't have IMA either. So we're going to need all three equations here. Let's start with the first one. We can use this equation, IMA equals DE over DR. We have both of those, so we can use this equation to find the IMA of the machine. I'm going to do that right up here. Let's start up here. IMA equals dE over dr. and that's going to give us DE is 4. Oh my goodness, I made a mistake back here. DR is 8.5 inches. Close call there, folks. Close call. 8.5 inches, not 4.5. Alright, let me switch back to red. IMA is going to be 4 over 8.5. So let's go to my calculator here. 4 over 8.5. It's going to give me 0.47 is our IMA. Now that's good because remember this is a third class lever where the IMA should be somewhere between 0 and 1, and 0.47 falls within that. So this is good. We solved the IMA. Okay, all done with that. Now we could go to get the AMA of the machine. Now I'm going to use the third equation. Let me switch colors here. I'm going to switch over to this equation. Percent efficiency equals 100 times AMA over IMA. And let's fill some stuff in. We know the percent efficiency is 88. So 88 equals 100 times AMA over 0.47. 0.47. All we have to do is solve this equation. Let's divide by 100 on both sides, and then multiply by 0.47 on both sides. So I've got to do this math. 88 divided by 100 times 0.47. 88 divided by 100 times 0.47. 0.4136. So AMA comes out to 0.4136. Now this checks out too, because if you remember, the AMA, the actual mechanical advantage, should always be less than your IMA. So we have 0.41, which is less than our IMA, which is 0.47. So everything's checking out so far. Now that we have the AMA, we should be able to work out some of these force numbers. So let's go to the bottom of the screen here. I'm going to switch to blue. Let's start with our third equation, or our middle equation. AMA equals FR over FE. Our AMA is 0.4136. Now at this point we need to decide which spring we're going to solve for, right? Because they each have different resistance forces. Keep in mind we're using the same set of tweezers for each of these tests, so the IMA is dependent on the measurements of the machine. Those are not changing, right? The 4 inches and the 4.5 inches, that's not changing, so the IMA doesn't change. Also, the AMA is dependent on how well the machine works, like how frictionless the tweezers are. So the AMA is not going to change either. The machine itself is the tweezers, and we're using the same pair of tweezers for each test. So the only thing that's actually changing is the strength of the spring, which means the strength that we push with will also be different. So let's go ahead and do this let's do the steel spring to start off with. So AMA equals, our resistance force is 3 pounds over FE. We have to solve that equation. So FE would equal it would be, cross multiply here, it would be 3 pounds divided by 0.4136. And that's going to give us, I've got to do my calculator here, 3 pounds, 0.4136, 7.25. Notice that we got pounds from the top measurement. The bottom measurement is the AMA, which has no units, so we just end up with pounds, which makes sense. We're solving for the effort force. So this force here would be 7.25 pounds. Now, to solve for the other springs, the silver spring and the brass spring, we would do the same thing that we just did for steel, except when we go to plug in for resistance force, we would use 0.7 plugging into there instead of the 3 pounds. And then same for brass spring, we would just use the 1.5 instead. So the AMA, the actual mechanical advantage, is not changing between these 3 springs because we're using the same pair of tweezers. The resistance force changes, which means that the effort force will also have to change accordingly. So you would use the same process that we just used to solve the remaining spring values, or the effort force values. Okay, hopefully this helps. Good luck solving this problem.